Hey, and welcome to the video. So if you ever wondered how come Git is so fast and what kind of voodoo it uses under the hood to make those merging of branches actually work, then this is the video for you. After this video, you should know where you are in a Git tree and never lose anything committed ever again. So let's jump into it. You're pretty good with Git, but you're wondering why? How does the branching and merging still work and doesn't have people screaming like it used to do for Subversion? And if there's some people out there that have used CVS in the past, they know what a true pain that could be. Git is different. Git actually makes you want to merge. And how does that trick work? In reality, Git uses the same tricks over and over again in different configurations. And to visualize that, I've got a couple of toys. Now, I could draw you guys a diagram and use that to visualize it, but the toys is just a lot more fun to do for me as well, and make it obviously clear that Git in reality is really simple. Let's dive into commits first. We're going to start with an empty directory, and in that directory you're going to run git init. Git init creates a .git directory, which you can see as a file-based database to keep track of your changes. That's a bit of an oversimplification, but it will do for now. I'm going to move aside a bit and show you guys a terminal here so you can see what commands we're using. After doing this, there is nothing in it yet, so we'll add a couple of files. We'll keep to time-honored traditions and add a hello world.python file, and because it's Git, we'll also do a default readme. After adding those files, Git still doesn't see anything. If you do a git status, it will show the files, but nothing actually changed inside that Git database. This is because we didn't tell Git to do anything yet. To do so, we'll do git add. And once you start doing that, something does change. Git creates a commit in the staging area. The staging area doesn't really make part of the database. It's a place where you can prepare a commit before it happens. But for all purposes, it's a full commit as Git will do once you do a git commit. Now, at this point it can change. You can make any modification to it you like and it will be fine. In the end though, at some point once you do a commit, the real magic happens, and that is that Git will take all the changes that happened, and in this case, because nothing happened, it will just say add file and the changes go from nothing to whatever in the file, and give it a unique identifier. That unique identifier is important because that's how Git knows where it is in the change structure of it. And after adding this, it will also add a couple of labels. Now normally these labels are already there, but because we're starting with a new commit, it will use the defaults. The first one we'll talk about is the master. Master branch is just the default name for the first branch. And you can name it anything you like. You can name it Brussels sprouts, kangaroo, whatever. But for the default, master will suffice. Another thing that gets added is the head label. And the head label moves, and that actually tells Git where you are in the code base and what code is checked out. It's used because when a change is made, Git needs to know where it's going to stick it into the tree. Now we're going to use a little bit of movie magic so I don't have to hold these things up all the time, and I'm going to move these over here. That makes it much easier for me. Now let's add a couple of commits. So as you can see, it's not very readable though. I'm going to change that by making it into a more graphical diagram. And I'm also going to make sure that there's a bit more space to show you the diagram in the terminal. Now I'm going to do that by moving over here. Excuse me while I bring in my microphone. And move the diagram over there. Now we have space for the diagram and the terminal, and to keep it readable even if you're watching this on a smaller screen. So we have our first commit, and we're going to add a second commit. So what happens is that you start working on your code changes, a new commit gets added, nothing has changed. This is the staging area as we just talked about. And then the moment you commit, it gets a unique identifier, and Git moves head to there because that's your active code base, and it moves the active branch there, in this case master. This is the most basic stuff that happens. Every time you add a commit, head and your active branch get moved up into the commit tree. So here we have a to commit Git tree. Now say that we want to start a branch. We're going to work on a feature. We want to spend some time on that. So I say git branch feature. Okay, it puts an extra branch there. Nothing really changed though. It just adds a label. And this is the trick with Git. Git doesn't do very magical stuff. It just moves labels around a static commit tree. Now if I do a git checkout, then for all sense and purposes, head is now attached to feature branch. And what this means is that if you do a commit, and we'll skip the staging bit, then head gets moved as usual, but instead of taking master with it, it takes the feature branch with it. Now, the feature branch is one commit ahead of master, which you can see, and if you want to do a merge, so your feature is done and you want to merge it back to the master branch, Git does a very simple trick. You do a git checkout of master, meaning that the head branch moves towards master, and now you're behind this commit, and then you say git merge feature branch, and Git says like, hey, this is connected. I know this. I don't need to merge anything. All I need to do is move my labels up. So no merging happens, no files are changed. The only thing that really happens is that Git goes towards commit on top and moves the labels there. And this is what a fast forward merge really means. All it does, it moves the labels forward. And that's the fast forward bit. Now we'll get into what if things get a bit more complicated and there's actual changes on two sides. Let's get into that. Okay, so now we're going to make it a little bit more complex. You've been working on your Git tree and you have your own feature branch with your own commit in it, and there's a master branch, and that one's behind you. Somebody decides to do some actual work and make changes. Now this becomes a problem, because if you want to forward now, if you want to do a merge, then Git says I can't, because there's differences. If I can't move this up, Git cannot go down and up again. So if you want to be able to merge this, you have to do something different. You have to do a merge. And so say you're working on the feature branch, let me put the head there, and you want to do a merge, then what you need to do is make a new commit, and I'm gonna add that one to it. And basically you'll tell Git to merge master into your feature branch. So what happens is Git makes a new commit with an identifier, as you can see on this one. And this change has both your change in it and the change in master. Now, if you would say merge my feature branch in master, so you would check out the master branch and you would say git merge feature, it would work because Git would know a path up. In that case, all the labels get moved up and all branches have all changes because everything can be followed down. This one has both changes. If I would check out D, for example, I would not have this commit. So the history of how things were separate ones and how they were merged is kept within the Git tree, but the branches itself are no longer different. This is in essence what Git does with nearly everything. It connects them together with the parents attached back and moves branches up just by moving labels around and having merge commits that have two parents instead of one. And then this one also has the logic. So if there's like a conflict and you resolve the conflict, the resolution to getting those two things merged is over here. Thank you for watching my second video on Git. I hope it was informative. Unfortunately, I won't be able to do all the videos in one go. I'm gonna aim at a bi-weekly release schedule to get all these videos out there and to get the basics out there. If there's any topic about Git you specifically want to hear about, be sure to comment it or send me an email. And if you want to be notified for the next videos, use any of the methods available. I put an update on Twitter. You can follow that. You can like, subscribe, use the bell if that's your thing. And hopefully see you again in 2 weeks. Goodbye!